Look at this shot. The lighting, the pacing, the exact tracking movement down this neon-lit hallway. Most people trying AI video for the first time end up with warped faces and chaotic movement because they type a quick prompt and hope for the best. To get results like this, you have to stop treating AI like a slot machine and start treating it like a camera. Welcome back. I'm Madhukar, and on this channel, we break down professional tech workflows so you can actually use them. Today, we are looking at Google Flow 2026. The platform has been entirely rebuilt. It brings image generation, video models, conversational editing, and music production into one unified workspace. To show you how the pieces connect, we are going to build a consistent 5-shot sci-fi laboratory sequence entirely from scratch. The reason most beginners struggle is that they skip right to text-to-video generation. They try to describe a character, a location, and a camera move all at once, which confuses the model. By breaking the process down, establishing our location first, casting our character second, and filming third, we maintain complete visual control over the final output. When you feed a vague prompt into an AI model, the model has to guess what you want, and those guesses result in messy, unusable footage. To fix that, use a strict 7-part prompt formula. The camera block dictates motion using exact directorial terms. The lighting and style blocks use specific keywords to tell the engine how to render the mood, ensuring your colors and shadows stay uniform. Let's apply this to draft the prompt for our first shot. We define our subject as a futuristic research facility, set the environment to a dark Martian landscape, keep the camera static, and lock in our neon cinematic lighting. Sticking to this strict input structure removes the guesswork for the AI. You stop getting random artifacts and start getting reliable visual assets. Step 1 in the workspace is image generation. Google Flow uses a model called Nano Banana 2 as its default for static images. This operates on a free, unlimited usage tier, meaning you can generate as many as you need to get the look right. Paste that exterior prompt we just drafted into the prompt box, set the aspect ratio to 16:9, select Image Mode, and click Generate to establish our base location. Next, we need our lead engineer. Write a new prompt focusing entirely on his face, age, and uniform, and generate a clean portrait. This establishes our character. To place him in the scene, upload that portrait into the reference image box. Then update your text prompt to describe him standing inside the neon-lit laboratory we built earlier. Flow reads the reference image and places our exact character into the new environment. Creating these static frames costs nothing and locks in your character design. Doing this before you spend credits on animation ensures your engineer won't randomly change his appearance halfway through the sequence.
Once the images are locked, we move to motion. This is handled by the Veo 3.1 video model. Unlike the unlimited image generation, free accounts have a strict limit of 50 video credits per day. This chart shows the credit cost for video tiers. Leaving settings on quality for a draft exhausts your daily limit. Instead, use light to test camera moves, fast for standard workflow, and save the 100 credit quality tier for your final render. To animate our engineer efficiently, we use a feature called Ingredients to Video. This bridges the gap between our static references and the motion model. Select the Ingredients tab. Upload the static image of our engineer in the lab into the reference slot, and in the text box, type your camera instruction, like smooth tracking shot moving backward. Then click Generate. Because the AI sources the visual from your provided image, the character retains their exact identity while performing the requested motion. When you need a specific, complicated visual transition, you use the Frames to Video tool. In the interface, upload 2 separate images. Place the image of the laboratory control console in the starting frame slot and the image of a deactivated robotic unit in the ending frame slot. Write a bridging prompt like slow cinematic camera pan left. The model calculates the spatial difference and generates the movement between the 2 frames. If you notice a small mistake in a generated clip, you don't need to throw it away. Google Flow includes Gemini Omni, which features an insert tool for precise in-platform corrections. Select the object you want to change in your video, open the prompt box below it, and type an instruction to replace it with a datapad. The system edits the existing footage, matching the lighting and shadows perfectly.
These conversational tools let you refine the footage after the fact, allowing you to actually act as an editor rather than just a prompt writer. Now that we have all 5 clips rendered and corrected, open the Scene Builder workspace to sequence them together. Drag your individual clips into the timeline. You can trim the excess frames off the ends of the clips and arrange them into a logical narrative order. When we play it back, we see the results. The lighting is uniform, the character is identical in every shot, and the motion is deliberate. Now we have a complete, cohesive sequence. We achieved this by relying on 3 core practices: sticking to the 7-part prompt formula, locking in our free images first, and managing tiers to conserve credits. To get reliable results from AI, you have to approach it with a structured workflow. It is a production studio, and learning to use the tools systematically is how you dictate the final output. If you found this breakdown helpful, subscribe to the channel. We will continue exploring technical, step-by-step workflows to help you build better projects. Thanks for watching, and I'll see you in the next one.